Hello and welcome to my channel. In this video tutorial, I'm going to solve problem on test of hypothesis. I've made a video on the introduction to test of hypothesis where I've introduced a lot of concepts. So here in this video, we want to see how we can demonstrate using some of the parameters we've introduced and the formula associated with it. So if you're new to this channel, please consider hitting the subscribe button and also like this video. And then if you feel you have other learning colleagues who will need to see the solution with you, please ensure you share this video and also drop a comment if you found this video helpful. Alright, so this is a problem that we need to analyze, and the problem reads: the distribution of age of a population of a particular population is normal with the population standard deviation, which is the symbol, equal to 5. The following random sample of ages was drawn from the population. Which are these values? So one, we want to determine the 95% confidence interval for the mean age. And the second, we're going to test for this hypothesis that the mean age is 23 years. So I would like to start off this problem with stating the necessary parameters and then start solving it right away. So the first thing I will do is to bring out the given data, and we know that the population standard deviation is equal to 5 from the equation. And it shouldn't be strange to you when I call this the population standard deviation. If you're not familiar with the symbols I'm mentioning, in the linked in the description of this video, I'm going to leave a link to the video that introduced the basis of these symbols and their meaning. So what you need to do is just to check through the video by the link I'm going to drop, and then you get every necessary information for yourself. Alright, so the next thing we're going to introduce is that if we check through the equation, we have the mean. They said the following random sample of ages were drawn from the population. So that means the mean, of course, no use per x of ungrouped data will be equal to, how do we get the mean? We have been given these following samples. So what we need to do is to add up all of them and divide by the total number we have here. And if you count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 25. So the total number we have here is 25. So we just have to add up all these values. We have 18 plus 14 plus 23 plus 23 plus 18 plus 21 plus 22 plus 16 plus 21 plus 28 plus 12 plus 19 plus 22 plus 15 plus 18 plus 28 plus 24 plus 22 plus 18 plus 13 plus 18 again plus 16 plus 24 plus 26 plus 35. The whole of this shall be divided by 25. And what is this 25? That is the sample size. If you count all these numbers, they are up to 25. So you divide this by 25. And by the time you punch through your calculator, you have this mean to be equal to 20.56. By the time you add up all these values and divide by 25, you have this value. All right. So I did not want to go through the process of doing this with you because I know I'm intending to make this video as short as possible so that you can be able to get the necessary information. All right. So if you read through the question, the I part of it is for us to determine the 95% confidence interval for the mean age. So let's start off with that I. So for us to get the 95% confidence interval, you should know that this is equivalent to 0.05, and this is the symbol for the confidence interval. How do we get this 0.05? If you divide 95 by 100, 95% means 95 over 100, 95 over 100, and there will be 0.95. So you have to subtract this value from 1, and you have 0.05. And this value is for the symbol, which is for the confidence interval. And this has been discussed in that video. So make sure you watch that video if you've not. All right. What are we supposed to do now we've gotten this? We have to introduce this formula, which is the mean plus or minus the z of 1 minus alpha over 2, which is the confidence interval divided by 2, dot se into by x. Let's term this to be our equation 1. So this is the formula we're supposed to use, and then we're going to define all these properties. So how do we get this z 1 minus alpha over 2? It is simple. So this z 1 minus, what is alpha exactly? We've defined alpha to be 0.05, right? And this will divide by 2. And when that happens, you have z to be equal to, when you divide this by 2 and subtract it from 1, you have 0.925. And then if you check this on the z table, the result will be equivalent to 1.96. This video will not cover checking how to check the t table and also using the z table, but I suppose by now you should have an idea. But if you don't, I'll make another video to explain how to make use of the z and the t table. But just know that this value, this is the equivalent of it when you check it on the z table. So that means we need to work on this, which is se be equal to, we have this our standard population mean or deviation to be this over, that's the formula, over the square root of n. And what is this n? We've already defined this to be the sample size, and then we know the sample size already, and we also know this, which is, this is 5 from the given question, and this particular one is 25. We've gotten it already. So we check the square root of 25, and the square root of 25 is of course 5. So we have 5 divided by 5, and then the result of this will be 1. So from equation 1, from this equation 1, this is the whole of that equation. From equation 1, we will need to plot in the values we have into the equation. And then what is this bar x? Bar x is 20.56 plus or minus, we have this whole value to be 1.96. all right, and this will multiply by the whole of this give us 1 by 1. So that means we're having 20.56 plus or minus 1.96. So that is to say, we're going to check in for the positive value and also the negative value. For the negative value, we have 20.56 minus 1.96, and if you punch this on the calculator, this will give 18.6, and then 18.6 approximately is 19. All right, so we're also going to check the positive value of this, and for the positive value we have 20.56 plus 1.96, and if you add this up on the calculator, this should evaluate to give 22.52, so which is approximately 23. All right, so now we've gotten this. It shows that we are 95% confident that the population mean is between, then let's use the two values we had, which is 19 and 23 years of age. All right, so that has covered for that problem, but we still have another thing we are asked to calculate, which is the II. The II we're asked to test. We've calculated the first one. We're asked to determine the 95% confidence interval for the mean age, which we have just done. The second one says that we should test the hypothesis that the mean age is 23 years. Okay, so this is how we're going to work on that. How do we test for this? Before we do that, let's bring out the necessary parameter given. Remember that we have the mean to be 20.56. We also have the sample size to be 25. The reason for this is known. The population standard deviation is known to be 5. Why we are doing this is because we need to know the formula we're supposed to use, whether the Z statistic or the T statistic. So we have the confidence interval to be 95%, which has an equivalent value of 0.05 when you subtract this 95% from 1. So you have this. So let's test for the null hypothesis. The null hypothesis will give us the hypothesis mean, which is 23 years. I think that is captured in the question where we are asked to test the hypothesis that the mean age is 23 years. So that's the hypothesis mean, that's 23 years. But the null hypothesis, in that other video that I told you about, either we use H subscript A or H1 to represent the alternate hypothesis. So this is the null hypothesis and this is the alternate hypothesis. This alternate hypothesis is not equal to 23 years. This shows that this is a two-tailed test, and because it is a two-tailed test, if you want to represent this in the normal distribution, then you have this. I like starting it like this, and we have this. So because it is two-tailed, it's a two-tailed test. This is the shaded region or we have it with the critical region. So here we have 0.025. That is alpha over 2, and you know that alpha is 0.05. When you divide that by 2, you have this. Here 2 is the same thing, 0.025. You need to label all this on this. You know, this is the fail rejection region, or we call it the critical region. And then notice that we have 1.96 here, which is a positive, and then we also have this part to be negative 1.96. So we want to check the value we want to calculate if it falls within these regions, whether it falls within the, here is the center, and then we have here to be 0.9. What was the value? Was it 925 or thereabouts? Yeah, 0.925. And I think that's that for this. So we've represented all the information on the distribution table. So what is the next thing? Let's use the formula, but we notice that the population standard deviation is known, and because this population standard deviation is known, we're going to use this formula. We're going to use the z calculated value formula, which is equal to mean minus this u naught, and then because this is known, half of the square root of n. And we've introduced this formula in that video I mentioned, so consider checking out the video. And if you've not also subscribed to my YouTube channel, please, you can like this video while you're watching, and please hit the subscribe button. The reason for which you're doing this is to help me grow my channel. And also don't forget to turn on the notification bell, because I'm still going to solve more problems on this. So when I upload new video, you get notified automatically without having to share the video. So what do we need to do at this point? We're going to substitute the value we've calculated or we have into this formula. We know that this mean is 20.56. When you subtract that by 23, and then we have this given as 5, the population standard deviation, and this divided by the value of the sample size is 25. It's 25. So what we need to do here is to subtract this, and if you punch this on your calculator with me, you have negative 2.44, and this will divide by the square root of 25 is 5, so we have 5 divided by 5. So this value will give us minus 2.44 divided by 1, because 5 divided by 5 is 1, and when you divide minus 2.44 by 1, you still have minus 2.44. So therefore the z calculated value will be minus 2.44. So what does this mean? This falls within the critical region. It falls within this, if you check it down there on this particular lane, it keeps going, it is within this region. That's where it falls. All right, so because it falls within that shaded region, so we could just make our conclusion like this: since the calculated value of z falls in the shaded region, we reject the null hypothesis and conclude that the mean age is significantly different are different from 23 years. So that's how we make our conclusion. And then I hope you found this video helpful. That's just a solution to this problem. If you found this video helpful, please hit the subscribe button, like this video, share this video, drop a nice comment. That will encourage me to do more video, and also make sure you turn on the notification bell so that when I upload a new video, you get notified. Thank you very much for watching, and stay tuned. I am Instructor Allison. I'll see you in the next video.